Hello, AT Physics students. Unfortunately, I was not able to come to this morning's class because I had a physio appointment, so I have this little video to help you out. You're going to be doing the following moving crate activity, which is going to be introducing you to some of the basic concepts of coding in our AT Computational Physics course. So, first thing we need to do is you need to find this Google document called the moving crate activity. A couple ways of doing that. You could either let's see over here. You could either go to Schoology, if you don't remember how to access my Google Drive folder, go to your course, all right? And in that course, you can click on Google Drive folder, which will bring you to the student shared folder. Okay, I'm just gonna click on this once more. I'll close Schoology, and I'll be able to get into, the Google Drive folder. In that Google Drive folder, we have a folder called Coding. And in the Coding folder, you have moving crate activity, or I guess you could have just searched for moving crate coding activity and you should be able to find that one. Okay, so once you find that activity, it's going to be asking you to do a bunch of tasks. All right, I'm going to give you a basic set of code. It's hyperlinked right here. All right, under computer code. It's going to bring you to a website called GlowScript IDE. Okay, we can be doing our coding on our computer through the desktop. We could have a program called VPython, but it is also easier to actually use GlowScript. It allows you to do the coding through a website engine, okay? And so you can load up all the programs and save them online and access it wherever you are. So this is a lot easier to use. Before we can do that, you're going to need to create a GlowScript account. All right, so I'm going to go here in incognito so it doesn't understand who I am. So I have glowscript.org. So you're going to need to type in glowscript.org. Don't be in incognito. Just use your normal SES Gmail. All right. Then click on Sign In. When you click on Sign In, this is where I would recommend that you sign in through your Google Gmail at SES. All right. Type in your email. Okay. Go to Next. Then type in your password and then click on Next. And then you should get to GlowScript. So for now, I'll just close this and I'll just open up GlowScript on my own. It's probably going to be already synced and already know who I am. Yes, it is. You can see it says signed in as Ian Page. Okay, now a little bit of introduction about the GlowScript. All right, in here I have a bunch of folders, so you can create folders for each chapter that we do. All right, remember that normally the programs that you create are going to be private, okay, so that you can't share them. If you would like to share your programs with me, which you'll have to do at some point, or your friends, you'll need to put them in the public folder. Okay, everything else that's in private or any folder that you've created will be basically private and no one can see it. Okay, you can add folders over here. Okay, so if you go into the moving crate activity, we're going to be investigating position and velocity. We're going to look at this crate that is simply moving along. So if you click on computer code in here and click on this program, it'll automatically go into that program and run it. You should see a block that is simply just moving it to the side. Okay, so hopefully you've done that. All right, you're going to, in this program, you can view it. And I would then actually take this code in here and just highlight it, copy, okay, and then go into your own GlowScript and then go create new program, give it a name. I don't know, you can call it moving.crate.activity. I'm using dots, by the way, because it won't accept spaces. So you have to put all like it has to be characters of some sort. Okay, so give it a name, create. All right, it's going to create a blank program in here. Then I'm going to paste this in. I may want to get rid of GlowScript 3.0 because we're now on to 3.1. And then you're going to be working with this code that I've created and asked to do a number of things. Okay, so hopefully you've got there. You've found the Google Doc called Moving Crate. You have gone into this program and made a copy of that code so that you can manipulate it yourself. All right, and then you're going to complete the following tasks, numbers 1 to 11, the best that you can. And you can try to do them all by yourself and then maybe check at the end of this video, or you can just pause at different points in this video as I help you out if you're stuck on certain things. So maybe a quick note before we jump into coding. There is a file or Google Doc that we created a couple years ago and kept on improving it. It's called VPython documentation. If I double click into that, it's a document that was created with the help of a lot of our advanced CS students. And in here, it gives you help on all sorts of things. So in the introduction of GlowScript, just kind of like what I was running you through right now, there's a bunch of documentation of that. Maybe the easiest thing to do is to just kind of look around in here, but maybe if you want to, let's go to the first thing, for example, making 3D objects. So I'm just going to click on that heading here. It's going to bring me right into the spot where it talks about making 3D objects. Why? Because let's talk a little bit about that. So if you go back to the coding in GlowScript, and you can see the program that we've created here, you can see here, by the way, it's just a comment. It's grayed out. Notice it starts with a hash mark or pound mark. Okay, so this is just simply, it's just a piece of text that you put in there just to kind of tell yourself and whoever's reading your code what you're doing in the next few lines, or what you're doing. You could also do it like on the side of a line. You can type in here, let's see here, I can type in an asterisk on there. Let me go maybe over to this program because I can edit it. So I can go over here and just put hash and saying making the floor. So it's a comment. Now that's not going to execute anything, but it's just a comment for me. Okay, so in these two lines over here, we are essentially creating objects. One is creating a floor. So what kind of objects can you create? Going back to our VPython documentation, it talks a little bit about how you create objects. You can create a sphere, and down here is an example of that. Now, each object that you create has a number of attributes that you can assign to that. So you have here a ball or a sphere. All right, this object has a name. We call it my ball, and that object you're creating is a sphere. This part is an attribute. This is the position of the ball. So it's at 0 along the x-axis, 3,500 up, and z goes in. I should point out that this is a very three-dimensional kind of program. So if you run it, for example, all right, you can view that this block is moving across. And if I, for example, if I zoom in, I'm just basically holding two buttons and dragging across my screen here, or my trackpad. I can press the shift button to move it horizontally up or down, just holding the shift key. If I hold the command button, or actually, sorry, the control button, I can change the perspective that I'm viewing things. This gray bit is the floor, and this is the crate. All right, so if I go to edit the program, I have two objects, the floor and the crate, and they're both boxes. Okay, this floor has a position of 0, -30, 0. So I guess I should point out when you create objects, they're created in this space where it's along X is horizontally, vertically Y, and Z is going in and out of your screen. Okay, where is 0, 0? Where is the origin? The origin you might think would be in the bottom left of your screen, but it's not. Actually, it's in the middle, dead center part of your middle. So if you run an x-axis in the middle of your screen and a y-axis in the middle of your screen, that is where 0, 0 is. Okay? These are all the different objects you can create. Arrows, boxes, cones, helix. Okay, we'll get into all these things later on. Okay? Let's go back to that coded program. So here I create a floor. This is defining where it's going to be located, the position of it. Pos is just a short term for position. This is changing the size of it, which is going to mean that's 100 units horizontally, 4 units up, all right, and 12 going into the back of the screen. Here we're assigning the color of it. Okay, you can assign it all sorts of colors, red, green, blue. All right, you write color equals color.red. Crate is the box that we created. It starts at the origin. It has a size of 10 horizontally, 10 vertically, and 5 into the screen, and its color is red. Okay, and then we'll get into this a little bit in a bit later, but for now, go back to the moving crate activity. Okay, and what I would like you to do now is to kind of play around and learn by playing. Okay, so you need to complete the following task. So, first task is to change the size of the box and make it smaller. Okay, I would recommend that you pause the video at this point, try it yourself, and then play the video again if you're stuck, or take a look at it and see if you did it right. Okay, so press pause, and then I'll start up again. Okay, so what we need to do is we need to make this crate smaller. If you look at it right now and I press run, there is the size of the box going across here. Okay, how do I make it smaller? I need to change the size. Let's say I want to make it now only 5 horizontally, 5 vertically, and let's just keep the Z the same thing. So now it's perfect cube, 5 by 5 by 5. So now if I run the program, okay, you can see now it's smaller. Okay, so now go on to the next step, which is I would like to make the crate be not above the floor, that doesn't make sense, but put the crate on the floor, but on the left side of the screen. Okay, so go ahead and try that out now. Okay, the next part, we're going to make the crate be on the floor. So if we go into here, our program over here, we can see that the crate is sitting initially in the middle of the screen because it has a position of 0, 0, 0, so it's at the origin. But the floor is 30 units below. All right, so running the program, you can see that the crate is just floating above here. We need to make the crate be over here on the left-hand side. So hopefully you realize that you need to change the position of the crate. Let's not change the position of the floor. Let's keep the floor the same because it's at the bottom. So you might be like, well, let's just change this to -30. Okay, fine, let's do that because that's the position of the floor. And you run it, and you might notice that the crate seems to be moving inside the floor. Not so great, huh? That's because when we talk about the position, we're looking at the center of the crate. And then also when we're talking about the floor, the center of the floor. So if the floor has a vertical width of 4, then really it's the middle of that floor is being positioned at -30. So if you go a little bit above that, then that would be actually -28 would be the top edge of that floor, right? So if we put the crate, say, at -28, well, also remember that it has a size of 5, 5, 5. So maybe you have to be another 2.5 above that. So maybe -26, let's say. All right, but it's 2.5, so maybe 25.5. How did I get that? So I know that the top edge of the floor is 2 above -30, so that'd be -28. And then I know that the crate has a vertical height of 5, so that if the middle of it is 2.5, I need to be another further 2.5 above that. So 2.5 plus 2 gives you 4.5. 4.5 added to -30.5, 30 gives you -25.5. So let's see if this runs it and works, and we have a crate that seems to be sitting on the top of the floor. That looks like, yeah, good. Now we just need to now make the crate be on the left-hand side. So we're going to change this horizontal part negative here and make it, I don't know, well, the size 100. So if we put it at, say, -50, all right, let's see. Good, but the only thing I'd say is it's just sort of on the edge over here, so we want to probably account for the fact that, again, it's 5 units, in width, so we might say, I don't know, -47, let's say. And so now as we run the program, the block is starting on the left edge and it's moving to the right. Okay, so we've done that task. Now let's go on to the third task, which is I want you to change the color of the crate. Change it to whatever color you want. So take a moment, pause the video, and do that now. Okay, so now we're changing the color of the crate. Okay, so right now it's red. So we're going to change that color to something other than red. Now, whenever I'm trying to figure out what I can do, and I can't remember the documentation or the syntax on GlowScript, I just simply Google it. So I just type in, I always start it off with, say, GlowScript. All right, and then I just type in what I'm trying to learn about, like color. So I type in glowscript.color. Usually the first hit in my search is something with the GlowScript, and then there's a help page. So here's all about the colors. So there's some pre-programmed colors that are already in there, like red, green, blue, purple, yellow, orange, cyan, magenta, black, white. But if you want something that's different, you can also create it too. So if I just want to change it to green, I would simply go into my GlowScript and I would go to my program and I would just change the color and do color equals color dot green. And voila, I should be now seeing a green crate moving across to the right. Great. Okay. But if you, let's say, want to have pink as a color, okay? So if I want pink, you'll see if you, on the help menu, you can actually set it to any RGB value that you want. So if you want that, we can just go into, just show you that. I'm going to type in RGB, red, green, blue, color pink. Just Google that. And I can see on Google it says pink has these ratios right in there. 255 is the maximum value of red that you can have, then 192 of green and 203 of blue. Okay, all the colors you can imagine, you can get, just depends on the intensity of red, green, blue that you have. So I'm just going to copy and paste that and show you how to do that right now. So if I go into my GlowScript program over here, instead I can say color equals vec, okay? And I'm going to just type in those values, but there's a little bit of a kicker you have to do on here. All right, I need the brackets at the end of this. All right, I need to go, it has to be a decimal between 0 and 1. So I have to divide this by 255. I have to take 192 by 255, and then 203 by 255. So now if I run the program, I hope I didn't do anything wrong here. I have a pink rectangle in here too. Okay, you could even do other neat things. If you kind of look around, you could even change the opacity. That means how transparent it is. You can even put pictures in there. Any picture that you find on the internet that it can download, you can overlay a picture. For example, if you have a sphere, you could overlay the topography of the Earth over it. Okay, so some neat things they can do. All right, let's go back to the moving crate activity and let's go on to the next thing. Right now, I want you to give the crate a different constant velocity. I don't know, something, let's say faster, okay, but going to the right. So go ahead back to the program and see if you can do that. Just pause the video and try it on your own. This is going to take a little bit more time to explain, but hopefully you have deciphered what the code is doing here. So let's go back to the code. Here we're setting up some initial parameters, okay? There's t, which is basically, I will add some comments that you might want to add in your own program. Here I am setting the initial time to be 0, okay? Over here, dt is just setting the increment of time, all right, to be 0.01 seconds, for example, okay? And then in this line of code, line 10, here I'm just setting the initial position of crate to be whatever it was initially. So here it says I'm going to define x0, which is some variable, to be equal to crate's position dot x. So what it does is it looks at x0 and says, look for object crate. There's the crate. Then you put a period in here because now it's looking for a particular attribute, and it says, okay, I want the position attribute, and then another period because I want the x value of that position. So it's going to look at crate, the position, and the x, which is going to be looking for negative 47. So here it's assigning negative 47 to this value x0. Okay. Over here, I'm now also defining another variable, v equals 10. And I guess I should point out, in case this is brand new for coding, we can assign values, variables. So if you go over to your VPython documentation and you look at, say, types of variables, and I just hyperlink to that, you can see in the help menu, it talks a little bit about the types of variables that you can have. All right, like a and b. 3 here is just an integer. All right, and then I have like negative 2.4. And so you can basically have different types of variables. One is simply just a number, okay, a scalar quantity. You can also assign variables to have vector quantities. So it has an x and a y and a z. Okay, all right, so lots of different ways that you can have, and we can get into list as well, but let's not worry about that. Let's just remember that there are two types of quantities for now. Quantities that can be simply just a number, a scalar quantity, or you can also have variables that are assigned as a vector. That means that it has an x and a y and a z components. And we'll get into that a little later on. For now, we're just going to be just looking at the number part of it. Okay, so we are assigning basically the speed or the velocity. Actually, probably should call this just speed because we're only looking at the magnitude of the velocity. All right, is 10. All right, and then we're telling that the initial position is, say, negative 47 in here. And then this is our time and keeping track of how much we increment time. Now this part here, lines 15 to 18, is something maybe new for you. We're creating what we call a loop. And I'm going to assume that maybe some of you have never learned any coding before, so I'll have to try to break this down for you. So if I go back to our little VPython documentation and you skip along down to loops here, you can see that we talk about loops in the documentation. So a loop is basically what it does is it tells the computer to perform whatever is in that block of code and keep repeating it over and over until, like, I don't know, you want to do it 10 times or something. So over here in coding languages is what we call a flowchart. And here we have like while. We're going to just do, most of the loops will be just while. So we're going to keep doing this until you no longer meet this condition. All right, maybe this will make more sense once I go to the program. So let's go back to the program for a second. So here I have a while loop. I'm saying while t, which is the time, while the time is less than 2, and it's originally started at 0, all right, and you have to use this colon sign here, and you'll notice as soon as you press enter on here, it'll automatically indent. Okay, that's a good thing in Python, because if you mess up and you put a little bit like that, it's not going to understand. It has to be very specifically this amount of indentation. Why? Because this bit of code here is our block of code that's going to be repeated over and over. So the first thing in here, you might be wondering, what is this rate thing? Well, computers execute things really quickly. So what the rate does is it kind of slows things down so you can see it. All right. So I usually set the rate to be the inverse of the dt. So if dt is 1/100th, then my rate is going to be 100. And I would use that same rule of thumb so that you could have the same basically runs as you see it. Now, over in this line, all right, this is where we're basically, I will say, updating the position of the crate. Now, hopefully, you might recognize this is an equation that we've been using recently in class. That x is equal to the x initial, all right, the starting position, plus the velocity, plus the time, or whatever it is at that point. So it just computes the new position, and then it relocates the crate to that new position. Then over in line 18, this is just incrementing time. So remember, time starts at 0, so then after it performs this line, it goes over to here and says, okay, add 0.01. So then it goes back to the top of this loop and says, okay, are you less than 2? Yep. Okay, let's do this again. And then it's going to increment time once more. It's of course going to update the position of the object based on the new time it's at. And so now the time is going to be 0.02. And it's going to keep doing this over and over until you get to, guess what? 2. Once you're no longer under 2 seconds, it will exit the loop, and then you're at the end of the program, and then you're done. So the question is, took me a long time to answer, is how do you change the speed of the object? Well, this v is the speed of the object. Right now, the object is going 10. So let's make it go, say, faster. Let's make it go 15. So that's all you have to do. Change that 10 to a 15. And if I run the program, now I should see my crate moving faster. Voila. Okay. Hopefully that all made sense. Okay, the next part is to go here and create a second crate, call it crate 2. You need to create that object, different size, different color, and place it over on the right-hand side. So pause the video and go ahead and try doing that. Okay, so let's go ahead and create crate 2. So go back to my GlowScript program, and I'm just going to copy this code here. Okay, I'm going to paste it again. I'm not going to create 2 objects that are identical, but I'm going to call this new crate, crate 2. I'm going to now not have it on the left-hand side. I'm going to have it on the right side. So it's going to be positive 47 at the same vertical height. The size, make it a little bit bigger. Let's make it like 7. Okay? And then let's change the color. I don't know what a color, but we'll take it and make it color.blue. Okay? So now if I run the program, hopefully I've created a blue crate over here on the right-hand side. That's it. Okay, so now the next step is I want you to give the second crate a smaller velocity than the first crate, going and make it move to the left. Okay, so pause the video and try that now. Okay, so now we're going to make a second object on the right side. We already did that actually, and we're now going to make it move to the other side. So I go to my program, let's edit it here. I'm going to make that blue crate move. Right now it's just there, I created it, but it's not moving because I need to change the loop in here. So I need to add another line that's going to update the position of the second crate. So let's just do this. Let's take this bit of code. Essentially it's the same almost, right? But we're going to need to do that for crate 2. Now maybe I might make purposely a mistake in here so you can see that I've got a little bit of error. So if I run this right now with crate 2, I'm sure I'm moving it, but you notice the blue one is like now relocated over the top. In fact, if you look at it and I zoom in, you'll probably see that the other crate is actually, I don't know if I can actually do that. It's inside there. You can't even see it. It's actually inside there. I can't do that. Anyway, the blue crate is on top of it because I need to update I need to set the initial position of the second crate too, because it's going back to the position of the first crate. So maybe I'll call this X02, and that's crate 2's position. So over here, that's going to be X sub 02. I also need to change the velocity of it. I need to have a velocity 2. All right, let's make it go at, I don't know, -10. Notice I use -10 because I need to make it go to the left. So now we're going to go over here and also change this to V2. And I'm sure a bunch of you are going to make little mistakes here because of you're forgetting to set the initial position for crate 2. You're forgetting to create the velocity of the second cart. Lots of little typos. You might make a little typo and then it doesn't run. So that's the art of debugging. Okay, so now I'm going to run the program once more. There I go. I've got the 2 blocks coming towards each other. Well done. So now you're on to the next part. I would like to have the crates meet sooner. So what would you do to make the crates move sooner? Okay, pause the video and go ahead and try to do that. Okay, so to make it go sooner, all right, we need to change the velocities, right? So we're just going to simply make these guys go faster. So I'm going to make this velocity be going, I don't know, 30, and this one go, I don't know, negative, say 20. Okay, and let's run it. Oops. And now they're going faster. And yeah, now they meet, right? Great. So, because I made them go faster. Okay, so hopefully you could answer number 8. Which lines of code make the crates move? Right? That's, go back over here. I'll answer that without you pausing the video. That's this part right in here where I'm updating the position of it. These are making the objects relocate every single spot on the screen. And so really lines 21 and 22 in my program are the places where I'm changing the position, which I'm making the crates move. Okay, now moving on here, we're going to how to figure out to stop the program once the crates collide so they don't move past each other. Okay, so take a moment to figure that out. Pause the video and try it on your own. Okay, so if I run the program again, I can see that the crates are moving past each other. A couple ways that one could look at this. You could figure out the time that they meet and then end the loop at that particular point in time, less than whatever that value is, and get the answer that way, right? That's one way, but I don't want to sit down and go through the number crunching. I'd rather not do that. Personally, I'd rather like to have a little condition here where I change. So by the way, hopefully you understand that it's really I need to change line 19 in order to stop them. So one way would be maybe to, you notice that crate 1 is on the left and crate 2 is on the right, and crate 2 has a greater position always than crate 1. So if you could say while crate 2.pause.x is a greater than crate 1.pause.x, or just called crate, then now it's going to continue the loop until their positions are no longer like the right is on the right and the left is on the left. So if I run the program right now, okay, you can see it's going, oh, but we have a little bit of an issue. They're overlapped. Remember that we're looking for the center to center, and if you remember, both of these guys have a certain size. Their size horizontally is 5. So you could say, well, maybe I subtract 2.5. Would that work? Let's see, 2.5. Because I know, why did I pick 2.5? Because that's half of 5. But there's 2.5 on the right crate and also 2.5 on the left crate. So maybe I should actually pick 5. Let's see. Hopefully you're playing around and figuring that out. So, oh, I went the wrong way. I should be actually adding 5. Let's try that, add 5. Okay, so that's the whole point of programming, is figuring out what works. And it still kind of looks like they're overlapping a little bit. So you might actually find that you could do while crate dot size dot x, add that in there, so that you're including the entire size of it, and see how that works out. Or take the two sizes and add them up and divide by 2. That would be one way of doing it. Okay, so couple ways of doing it, but we have to include the fact that there is a size to it. Okay, so now hopefully you're getting the two crates are going to stop when they don't move past each other. All right, and you could spend a little bit of time explaining how you determined when the program is going to end. And lastly, what do you think this motion that we're modeling? Is it accelerated motion? Is it motion that is not accelerated, that's constant velocity? Okay, this is already a long video. My hope is that you actually did a lot of this on your own and just figured it out by trial and error. Okay, have a great day.